Okay, so the agenda for today. Since I'm not sure if everyone is familiar with code coverage, let's quickly look at what is code coverage and why do we need code coverage and what can it do for us. And then we will dive into dotCover, which is our code coverage tool, which allows you to measure code coverage and analyze it and so on. Next thing we will do is introduce code coverage into our continuous integration environment. And we will do that by using the things that are available in TeamCity, but we are also going to make use of the command line runner that's available, just to give you some ideas on how to integrate some exotic testing frameworks or whatever into your CI process. And to be able to do that, we will also have a look at TeamCity service messages and several other tips and tricks that are available in TeamCity to get this working in case you are using any other than the defaults. With that, let's start with showing what is code coverage. If we look at Wikipedia, Wikipedia states that code coverage is a measure which can be used to describe the degree to which your source code is being tested by a particular test suite. Now, this particular test suite is sort of a vague thing, and the degree to which your source code is tested is also a pretty vague thing. So there's a lot of interpretations to what code coverage is. But basically, how I like to think about it is code coverage basically measures all the statements that have been covered or have been executing in your source code while running a test. And such test can be a unit test, can be an integration test, or even a manual test while running your application, a web application or a console application, and so on. So code coverage is basically checking which statements have been executed while testing your application source code. And to demonstrate that, I'm going to show you quickly how you can capture code coverage information when running an application from Visual Studio using dotCover. So this is not going to be running code coverage from unit tests or something. This is just going to be capturing code coverage from a running application. So what I have here is an application that allows me to enter D or T, and which will show me a date or a time whenever I'm executing this, and I can use Q to quit. Now, what I would want to do is measure the code coverage for this application when running this application and not hitting all the different branches that are in the execution path of my code. So what I can do is use the dotCover menu here, which you can install when installing dotCover. And I'm going to say I'm going to cover my startup project. And what will happen is dotCover will launch the dotCover console, in which I can get a snapshot or drop the snapshots that I'm capturing. And it will also launch my application. And in my application, I can now make use of the different features I have in there. So let's crash the application and capture code coverage information. Let's try that again. I shouldn't have entered the blank input there. So let's cover my startup project again. Show the date again, and then we quit. Now what will happen is dotCover will have gathered all the covered statements in my application code. So if we look at this new tool window which was opened, the code coverage results browser, we can see that 91% of my entire application has been covered. 91% of my coverage demo namespace, 91% of my program class, and 91% of my main method in there, which is pretty logical because I only have one method, but typically in a bigger application, you would see different code coverage percentages throughout your application. What we can also see here is that we have 2 statements of the 22 statements in total in my application that are uncovered. So what I can do now is go to the editor, and in the editor we can see exactly which statements have been covered and which have not been covered. So we can see, since during execution I've only been using the date feature, we can see that the green lines here, the green statements, have been executed. But since I've never executed the time feature, well, we can see that the time feature is still in red and that this line of code has not been covered. So what this allows us to do is test an application and see which parts of the application have been hit during execution. In this case, this was a manual execution of the application, and this can be very useful to check, for example, if we use one of the different features that are in the application, to check what's the impact of running this specific feature or using this specific feature throughout the application. But of course, typically, and especially in continuous integration scenarios, you will run code coverage in unit tests, which is what we will do in a minute. Let's first switch back to slides. All right. Code coverage, I've had a lot of religious discussions on code coverage. A lot of people say you should have 100% of code coverage all the time. I'm not sure. It depends, I would say. I would say code coverage is a tool which you can use to verify the number of statements that are being executed, which can be used to check which parts of the code are being executed during a test run, whether that's a unit test or a manual run. But I'm not sure, and I'm pretty sure it will depend on the type of application you are using, that you should always aim for 100% coverage. So for example, I'm an ASP.NET MVC developer. In MVC4, not all code paths can be tested adequately because there's some relying on IIS, for example. So 99% or 95% or maybe 90% may be good as well. So code coverage should not be a goal. Code coverage should just be a tool to check what you are testing and how good you are testing all the different lines and all the different branches in your code. Am I saying that because we shouldn't aim for 100% coverage in all cases that we should not care about code coverage? No. Still, we want to use code coverage and verify the code coverage of our application to make sure that we are not forgetting something that should have been tested. For example, if you have a very complex class or a very complex method with a lot of if statements and so on, typically what you would want is a lot of code coverage on that type of classes because they are potential sources of defects in your application that you are building and deploying in the end. dotCover is our code coverage tool, which you can use to capture which statements have been executed during a manual run of the application or during a unit test run. As we've seen before, we can see the number of statements that have not been covered versus the number of statements that have been covered. We can also see the percentage of coverage and so on. But there's a lot of other things we can do using dotCover. So what I've just shown you was just like the tip of the iceberg, because there's a lot of interesting things in there. And one of my favorites is the hotspots feature, which I'll show you in a minute. We can also filter and export the different coverage results we have. So for example, if you want to share the code coverage results, all the lines that have been tested and covered, the global percentages and so on, if you want to share those with someone from your team on a portal somewhere on your intranet, what you can do is export the results as HTML, for example, or as a PDF, and distribute that amongst your team members. One of the things I also very much like is navigating between code and test. So whenever you have first run your tests using code coverage, what dotCover will do is add another navigation feature which allows you to switch back and forth between the code that is being tested and the tests testing that code. So let's see what we can do with dotCover and go a little bit deeper than we've done previously. So what I'm going to do is make use of this funnel web application. And if you look on GitHub, I'm basically using Funnel Web, which is a blogging platform that you can use. Why did I choose this one to demonstrate all this? Well, it's an open source thing. It's relatively popular, and it has unit tests using NUnit, which is supported out of the box by dotCover. So let's open that one in Visual Studio, and let's have a look at how we can run our tests. So what we will see is that dotCover has this unit tests menu where you can see all the different unit tests that are available. Now, I also have ReSharper installed, and this thing has the same menu, so I can also view my unit tests and my unit test sessions. If you only install dotCover, what you will get is basically the ReSharper test runner integrated in dotCover. If you have ReSharper, dotCover will plug, or it will ask you if it can plug onto ReSharper, so ReSharper and dotCover will share the same unit test runner. So I have my unit tests here, and what I can do now is run them all, or use this little icon called Cover Unit Tests with dotCover, which is this one. And once I click that, dotCover will start running all my unit tests using the test runner and capture all the information that can be captured in terms of the statements that have been executed and so on. So let's cover our unit tests, and as you can see, the test runner will open and it will start executing my tests. And it just looks like the ReSharper unit test runner, or if you have dotCover installed, this will all look very familiar to you. So the tests are being executed, and while they are being executed, dotCover is capturing all the information that can be captured in the back. So once these finished, I will have my regular test output where I can see all the various tests that have been executed, and I can see if they have passed or not. And when all that is finished, I will be able to use the coverage tab below and check the code coverage as well. So let's wait for the unit test to run. There we are. And we should now also have code coverage information available. So with FunnelWeb, we can see that the web project, or the web project in my solution, has been tested for about 32%. The FunnelWeb shared project has been tested for 39%, or covered for 39%. So what I can do is, again, open this and see which namespaces have been covered and the percentage of coverage in there. And I can also navigate through the class level and even the method level. So if we take this model, for example, let's say tag, we have the constructor being tested for 100%, but all the other methods and properties have not been covered. So that's why the tag class only has 19% of code coverage. Again, we can double-click and open this class in the editor, and we can see using the green and the red color codes which statements have been covered and which statements have not been covered. What else is available from this tool window? Well, what we can do is, for example, export our coverage report to HTML, JSON to XML, and if you are using ndepend, which is a popular tool to analyze the dependencies between namespaces and classes and so forth, you can also export to a format that ndepend can use, so you can import it in there as well. Another thing we can do is change the grouping and do some filtering. So for example, if we are interested in only the namespace and type, we can pick that one, and the view on all the information will change, of course. Now, I was talking earlier about the hotspots view, and that's actually one of my favorites. If we click this little hotspots icon here in the toolbar, what we can see is all the classes that are risky. So, for example, this blogML import task we see here in the center is a risky class, or at least has a risky method, which has high cyclomatic complexity and has almost no or completely no code coverage. So if we look at this one, the blogML import task essentially has no coverage, while the cyclomatic complexity is 33. So if we look at this class itself, we will see that the execute method here has indeed not been covered, and it has a using, a for each. Within that for each, we have one if statement, another for each with some nested if statements and so on. So this is a very complicated method, and that's why the cyclomatic complexity of this method is also pretty high. And since almost no, or in this case no coverage was available, it's showing in the hotspots list. And generally, if you see a class or a method in this hotspots view, you can be pretty sure that that's a risky thing and that you probably want to write some additional unit tests or integration tests for it, so that the next time you run code coverage, it doesn't show up, or doesn't show up with the same priority, because this is a really risky method and class to have in our code base without having any tests in there. All right. So when do we perform code coverage? That may be a good question. Well, generally, I typically counter that question with another question, which is, when do you run unit tests? And typically, a lot of people, or at least I hope most people, are running unit tests on their developer workstation. So whenever they are developing and making sure their code is ready to commit to source control, I do hope you are running unit tests to make sure that what you are committing to source control is not broken. Of course, that's nice, and that's a first filter to make sure that code quality is high enough. But then again, you typically have a continuous integration process in place, where tests are run automatically on the last commit or every night and so on. So typically, your continuous integration setup is your view of the truth. It may be very nice that stuff is working on a developer machine, but you know the saying, it works on my machine. It may be that it works on my machine, but it may not be working on the build agent. And if it doesn't work there, it's broken. So everything you check in should build, compile, tests should be run, and of course we should do code coverage as well in our CI environments. If you're using TeamCity, what you can do is make use of the various build steps that are available that can compile your project or run unit tests. And we even have several steps that you can use to capture code coverage information as well. Actually, if you have TeamCity and you are using NUnit and so forth, what you will see is that dotCover ships with TeamCity and that you can just use dotCover on the CI server. So let's have a look at how we can do this in TeamCity and how we can work with TeamCity. So if you don't know TeamCity, TeamCity has a series of projects that you can create. And for every project, which is basically just a logical view on your world, so if you have one project that is back office, that will be your project. Within that project, you can create one or more build configuration. A build configuration is a series of build steps that can be executed, and those build steps make up the actual workflow of what happens when a build is being run. So let's see what we can do, and let's see if we can create a new project from a URL. So what I'm going to do is create a new project, and as the repository URL, I'm just going to pass the funnel weblog from GitHub and click proceed. And what will happen is that TeamCity analyzes the repository and checks whether it's Git, Mercurial, Subversion, ClearCase, Perforce, or any of the other source control options that are supported by TeamCity. So once that is done, and it seems to take a little bit, it really takes a little bit. Let's try that again. This may have to do with my internet connection. So let's go to my root project again. Or sorry, let's go to my projects again. Let's create a project from URL and let's hit the same repository again. And let's hope this goes a little bit faster this time. There we are. We can now give our build configuration a name. In this case, I'm just going to use the default build. And when we click proceed, what TeamCity will do is analyze whatever is in that repository and scan what are the potential build steps for this project. So what we can do now is pick any of these or configure the build ourselves. Since I know that this project builds using Visual Studio, I'm just going to make use of the Visual Studio build step. And what I can do now is run my build. And if everything goes well, we should now have a running build where we can see all the changes that are in there. Once we fetch the changes, we can see a build log of whatever is happening on the build server during the build. So you can see it's right now checking for changes in the GitHub repository. And whenever there's additional progress available, we can see it in here as well. So let's refresh that. Failed to collect changes. It seems that I'm having a connectivity issue on my build server, so let's try that one more time and see if it can actually fetch all the different changes online. Yes, now it does. So we see it's updating sources from GitHub, and now it's starting the first Visual Studio build step, which will compile the application and so on. Okay, now back to code coverage and unit tests. So I now have a build step which compiles my Visual Studio solution. Now, of course, what I want to add is an automatic way of running unit tests on my build server and running code coverage on there as well. So what I'm going to do is add a build step. And there's a number of build steps available in TeamCity. So, for example, we can run any .NET process or command line, fxcop, Gradle if you're using Gradle. If you're using Java, for example, you can run Maven and so on as well. And for running unit tests, we have an NUnit build step. So let's select that one. There we are. We can name our build step, but I'm just going to skip that because it's not a requirement. We can specify the .NET runtime for any unit, and I can select the assemblies which contain tests. So let's add my funnelweb.tests.dll in there. And once I have that, at the bottom here, you can see that I can also enable .NET code coverage. So this thing is available on many build steps that are available in TeamCity. And in this case, I'm going to say I want to make use of dotCover. And as I've said previously, dotCover ships with TeamCity. So if you want to collect code coverage using dotCover, you can simply select it in here and it will be available. Now, we've seen previously, if I switch back to my Visual Studio, we've seen previously that we also have code coverage for our test projects and various third-party tools that I'm using in my project. So what I'm going to do is filter my assembly so that I'm not collecting code coverage for my actual unit tests and one of the dependencies I have in there. Why not? Well, I don't think it makes much sense to capture the code that is being executed as a unit test because we want to test our application, collect code coverage for our application and not necessarily for the unit tests in there. So let's save. Let's run our build again, and this should trigger a new build which will again fetch the sources from GitHub, which has apparently already happened. It's now running my Visual Studio solution build, so we can see step 1 of 2 is being run. And now step 2 of 2 is being started, and step 2 was running unit tests with code coverage enabled. So if we look at the build log, we can see whatever is happening, and we can see, for example, that the JetBrains.cover console runner is being used as the code coverage engine there. So our coverage session has now been started, and unit tests should be running as well, and the results should be captured. Now this may take a little bit, because all the unit tests again have to execute on the build agent, and all the information has to be collected and merged into something that can be displayed in TeamCity. But once all that is done, we should be able to view code coverage. Just a side note, while the build is running, if you're using the NUnit step, for example, what we can do is view the unit tests that are being run while they are still being run. So the build is still running, and I can already see, for example, that my query integration test has run and what the result was and so forth. Let's go back to the overview. We can see that now dotCover is merging reports, so the build is nearly completed. Generating dotCover reports. Let's refresh a couple of times. It's generating the HTML report right now. And once finished, any moment now, yes, we should be seeing the code coverage summary. So already on the build overview, we can see the percentage of the classes and the methods and the statements that have been covered for my current build. So if I look at my code coverage tab, I can actually drill down into more detail. So we don't see the funnelweb.tests assembly here because I excluded that, but all the other ones are present. So I can now drill into the results and, for example, check all the different classes that have been tested. And whenever you compile your project using debugging symbols available, you will also get this inside the TeamCity interface, so you will be able to view all the different lines of codes and the different statements that have been covered and have not been covered while running tests for this application. So I think it's pretty neat, and there's a lot of information in there which you can use to view code coverage and correlate it with the unit tests that you have available. Really nice in my opinion. Okay, now this was all using all the defaults. I was using NUnit and so forth. Now how would we go about gathering or collecting code coverage for a different project? And the different project I will be using is script.cs. If you don't know this, script.cs is basically a command line console in which you can write C# applications. So you can simply script your C# application, run script.cs on top of it, and script.cs will run the application and make sure you see something on screen or your web application is running. Now I know they are using XUnit as a testing framework, so let's see if we can hook up XUnit inside TeamCity and see if we can capture code coverage information. So back to TeamCity, back to our administration, and let's create again a project from a URL. So I'm going to use the script.cs URL in here and proceed, and let's hope my internet connection doesn't break down again on my virtual machine and that we have some immediate feedback, and yes we have. Let's proceed again and go with all the defaults. It's now scanning all the different potential build steps that are available inside the script.cs repository. There we are. I know that script.cs is making use of this build.project, so I'm going to make use of that one and make that a build step in my application. Now, I'm going to make a slight change in there, because by default script.cs builds a release configuration which doesn't generate debugging symbols. And if I want to make use of code coverage, I of course have to have those debugging symbols available. So let's say that we want to build the debug configuration instead. And again, we can see our familiar .NET code coverage tool selection here. So again, we can select JetBrains.cover or any of the other tools that are available, but there's an issue there. As we can see, TeamCity notifies us that test coverage using any of these tools is only supported if we are using NUnit tests. And since script.cs is using XUnit, which I know a lot of people are using, we have an issue in collecting code coverage. So let's save this and see if we can fix this. Maybe let's run our build just to make sure that our application actually builds and we don't have any other issues there. So it's running, updating sources, and if everything goes well, we should be seeing some more output in the build log of the actual compilation, as well as unit test results and so forth. So it's running MS-build right now. We can see it is running MS-build, running one of the different build steps in our build project. It's running code analysis as well. And I think right after that we should be running XUnit as well. I'm doing this just to make sure that we actually have a working build before we go any further with configuring TeamCity in this case. So we can see tests are now running and XUnit is being run as well. So let's assume that everything will work. And in fact, I can already see that my tests are reporting results while I'm still running the build, and this is all XUnit. All right, awesome. So we've just seen that test results from XUnit were reported to TeamCity, and that we could see all the results of the unit tests while we were running them. And well, XUnit is using sort of magic to do this. What XUnit is doing, they are reporting unit test results while running using TeamCity service messages. So you can go to the URL there. I will post a slide deck online after the webinar as well. If you go there, you will find all the different service messages that you can pass to TeamCity. And such service message is basically just outputting a string to the build log, which is prefixed by --TeamCity. And whenever you do that, you have several options of posting data to the TeamCity server to report, for example, that a test has started or a test has finished. So the two service messages you see on screen here, the test started and test finished, are used by XUnit to report whenever a test is started and how long the test took and what the status of the test was and so on. Now if you go to this URL, you will also find that there's a lot of additional information that you can pass, such as, for example, importing data into TeamCity, which can be a lot of different types of artifacts, but in this case we're interested in importing code coverage from dotCover. So what we can do is also make use of a TeamCity service message, which you can also see on screen, and basically import a coverage.xml, which is the output of dotCover. So whenever we have that in place, and whenever we know that we can do this as an approach to report code coverage inside TeamCity, the only thing we still need is running our tests with code coverage, and that's the next thing that we will do. So dotCover integrates in Visual Studio. You can also run it standalone. And what a lot of people don't realize, or something that's not well known, in my opinion, is that you can also run dotCover as a command line tool. So what you can do is simply run dotCover.exe from the command line, and you're able to do several things with it, such as capturing code coverage information or exporting code coverage information to XML or HTML or whatever format you want to use. So let's see how we can do that. And to do that, I'm going to dive into this VM. And what I can do is simply run the dotCover.exe command from my dotCover bin folder, and you will see that you get nothing. I can run dotCover help, and I will get some help information. And we can already see that we can cover, we can merge, we can report, we can list, delete, analyze, zip, and a lot of different options. So in order to be able to run unit tests with code coverage, or run any executable for that matter with code coverage enabled, we have to create an XML file which can be used to configure dotCover. Now, since that XML file is sort of big, dotCover comes with a nice little command that we can use to generate that XML for us. So we only have to open and modify it. So let's say dotCover help analyze foo.xml. There we go. This has triggered dotCover to generate such an XML file, and what I can now do is edit that foo.xml in Notepad, for example, and configure my code coverage. So there's a couple of things we really need in here, and I'm going to add some line breaks there to separate those from each other. So we will need an executable that should be run when dotCover is enabled. We can also pass in several arguments to this executable, and we can specify the working directory in which this executable should be run. Apart from that, there's a number of other things that we can specify. For example, we can specify a temporary directory, which by default will be the system temporary directory, but if you want to see what's being generated by dotCover, you can set this to a folder that you know or you control and where you want to see all this information. We can also specify the output file name. This can be an HTML file, this can be JSON, this can be an XML file, or again the ndepend XML file. Depending on the extension, we may also want to specify the report type so that we can output HTML or whatever. So even when not using TeamCity and you want to generate an HTML report without having to open up Visual Studio and so on, what you can do is use this console runner and set the report type, for example, to using HTML. And what you can then do is run dotCover.exe from the command line and get a nice HTML report of whatever has happened. In the UI in Visual Studio, we can filter all the different types of assemblies, all the different types of modules or classes that we want to include. We can also include those in this configuration file as well. But I'd say check our blog or check our online help to see various examples of this thing. I've created one of these files before starting the webinar. I think it's in my folder where everything goes, ctemp. Let's say all files. There we go. So in this file, I've specified that my target executable will be the xunit console runner. As the argument, I will pass in my my test assembly that I have for script.cs. And as the output file, let's say I want to output coverage.xml. Now, whenever I run dotCover using this configuration file, we can run our unit tests and get coverage information out of it without having to open Visual Studio. So let's see how we can do that in TeamCity. So what I'm going to do is switch to TeamCity, of course, and edit my configuration again and add an additional build step. And that build step is not going to be any of the pre-configured build steps available. I'm just going to make use of a command line build step. And as the script, I will paste in a command which runs my dotCover.exe so that I have my my executable, my console runner running. So what you see here is that I'm running dotCover as an executable. As the parameters, I'm passing the cover command, which is triggering dotCover.exe to actually run an executable with code coverage enabled. I'm also passing in the script CS coverage.xml I just created on my build agent. And I'm also passing in a number of overrides to the target working directory and so on, because I want to have everything in my TeamCity checkout directory. This is not mandatory, but I like doing this so everything is on the same location and I don't have to put in absolute paths in my coverage.xml file. Now on this coverage.xml file, I'm using my ctemp here, and that's a path that is on my build agent. This is probably not best practice. This is just for demo purposes to make things a little bit easier. Typically what you want to do is include this file in your source control repository so that whenever you clone from GitHub or from Subversion or from Mercurial, you have this coverage.xml file which contains the configuration for dotCover available as well. But since script.cs is not under my control, I just took some projects from GitHub. I of course cannot put this file in there, so I had to do this little trick. So this command will run dotCover during my build, and it will fire up xunit and run my unit tests with coverage enabled. This will also, since I configured this in my script.cs coverage XML, it will output an XML report of all the various code coverage details that have been gathered while running unit tests. Now back to service messages, I want to import that specific XML file into TeamCity. So let's also simply echo a TeamCity service message and specify TeamCity that we want to import data of the type .NET coverage using the tool dotCover, and that my coverage.xml, which is the output of dotCover.exe, will be in the current working directory, which is, I think, fairly straightforward to do, right? So let's save this, and let's run our build again. And if everything goes right, we should be seeing our build being triggered, sources are being transferred, and my build is being triggered, and so forth. So let's wait for our build to finish. Let's maybe open up the build log so we get a little more information about what is happening in the build. Let's maybe close our MS build step because it's quite elaborate on what it's doing. All right, and now we see our command line step is running, the one we just added, and it's starting dotCover, as we can see here. xunit is being started by dotCover, and if everything goes well, we should now be seeing outputs that our tests are being run. So that's what we are seeing here, which is just the outputs of xunit. And whenever that is finished, I'm anxious to see if we actually get a code coverage report in there. But we can see what TeamCity is doing, and we can already see that it's merging dotCover reports, removing snapshot files, and so forth. So TeamCity has now been triggered to import the output from the stuff that we just did on the command line, which is fairly easy to do, and yeah, fairly easy to get code coverage information in TeamCity, even if you're using steps that are not supported out of the box. So, as you can see, our overview page now has code coverage available, or a summary of the code coverage. And we also have a code coverage tab in which, again, we can drill down into whatever is in there and see which statements have been tested and which statements have not been tested in my application. And this time using xunit and using the console runner for dotCover instead of using Visual Studio or any of the default runners that are in TeamCity. So again, if you're using xunit or any of those exotic BDD frameworks or the latest testing framework out there, and you want to capture code coverage, simply think about running dotCover from the command line and importing the data into TeamCity using a service message that you can pass in a build log. All right. Now there's one thing that I want to show you, and that is the TeamCity plugin for Visual Studio. So up till now, what I've been doing is using Visual Studio to develop my application and run code coverage there and so forth. The next thing that happened is I could have committed to source control, trigger the build, and then see code coverage in there. But to make the loop complete and make sure that we can work with all the data that we have available, what we can also do is install the TeamCity plugin into Visual Studio to open code coverage results again in Visual Studio. So whenever you go to your profile in TeamCity, so let's do that. You will see on the right that there are a number of tools available. So for example, if you're using IntelliJ or WebStorm or any of the IntelliJ-based IDEs, you can install a plugin for IntelliJ so that you can interact with the build server from there. There's also a NuGet feed available. There's a plugin for Eclipse. There's actually also an RSS feed giving you all the build results. But the one I'm interested in here is the Visual Studio add-in, which you can simply download from your own TeamCity server and install into Visual Studio. And I've already done that. So let's open up my script.cs project. I've already installed it, and you will see a new TeamCity menu appear in Visual Studio, which allows you to do several things depending on the source control system you are using. So for example, if you are using Subversion, what you can do is run a build right from within your IDE, which is a personal build where you don't have to commit source control to your Subversion repository until you know that your build is actually running. What the TeamCity plugin also provides is this coverage menu, which will connect to the TeamCity server and shows us all the different code coverage snapshots that are available on the build server. So let's select the one for script.cs, which we just ran. Click OK. And this will download the snapshot from TeamCity server, and we can see and browse all the results from within our IDE. So we can see that we have, for example, this missing assembly exception has coverage for one of the constructors, but not for all the other ones. We can see that in here, and we can also see this again in our editor. Now, as I was saying, to make the loop complete, what we want to do is find out the code coverage results from our build server. And we can see that, for example, for this REPL class, the execute method has been tested for 66%. So let's see if we can improve that a little bit. So we can see, for example, that the clear command and the reset command have not been tested. So these statements are all uncovered. So what we can now do is go to the tests or a test suite for that. And I'm just going to uncomment the tests that I created before. And I'm going to execute my reset statement, verify that this method has been called, execute my clear statement, and verify that this one has been called as well. And what I can now do is simply run all my unit tests again. So yeah, let's run the tests for this class. Or yeah, let's find all the different tests that I have available. And it seems that I closed my test window, so let's open them again. So let's run and cover all my various tests. And if all goes well, we should have our tests being executed. We're again capturing code coverage information, and we will now be able to see if we have better results or worse results than before. So if you now look at the code coverage, we can see that we still have 87% being tested. But if we look at the core, for example, we see that we now have 193 uncovered statements, and before we only had 185, which is sort of strange, but we also have more statements in here and less statements in the result that came from the build server. So if we now open up our REPL, let's go back to our REPL, we should see, and let me also make a little more room on screen, we should see that my reset method has now been tested, and we can see that we now have coverage for this method. Also for our clear methods, we can see that all the statements in there have now been tested. Well, previously in the snapshot that I received from TeamCity, they were not tested or not covered yet. There's one thing I forgot to mention earlier today, and that's actually one of the very nice features coming with dotCover, which is the navigate to or show covering tests. I don't remember the shortcuts, but apparently Control-Alt-KT. When you hit that one, dotCover will open up a nice pop-up window which will tell you which test is executing or covering the current statement. And by just hitting enter, I can navigate to that test. So let's do that again on a different statement somewhere, show covering tests. And we can see that this statement, for example, is being covered by a lot of tests apparently. And I can simply pick one from the list, navigate there, and start working on my, my unit test I have in there. All right, so in conclusion, what we have seen is code coverage and why we would like to have some code coverage of our application. So in summary, we want to have code coverage to make sure that we are testing the correct things and to know that most of our code, or at least the very important parts of our code, are being covered by unit or integration or manual tests. I'm not sure you should actually aim for 100% code coverage. I think it will greatly depend on the different projects that you have available. We've seen how we can use dotCover to capture coverage information in Visual Studio. We've also seen how we can integrate it using the XUnit runner in TeamCity. And we've seen how we can extend on that using service messages and use XUnit and so forth, or any different unit test runner to capture that information and get all that information into Visual Studio. So with that, if you have any questions, feel free to ask. I think most have been answered, but I'm not sure. Olga, do you have any additional questions?
Yes, thanks, Martin. I think most of the interesting questions were covered, and we'll publish a Q&A session with a webinar recording when it will be available within a week, I guess.
Okay, perfect. With that, I still have several resources if you want to go and play with dotCover or read more on all the techniques I've just shown you. dotCover can be downloaded as a trial from the website. There's a couple of tutorials available, including one on the command line runner. So if you're interested in using the command line runner with any other build step or any other framework inside TeamCity, have a look at that one. And yeah, it's probably also good to read up on the TeamCity service messages, because there are several other techniques of importing data into the build server. With that, more information and feedback can be found on the website. The issue tracker, you can contact me through email, and as Olga just said, the video of the webinar will be available on our blog later this week. Thank you for joining the webinar, and if you want to follow up on more webinars and so forth, make sure to follow us on Twitter. We're the dotCover account. Thank you.